Welcome to Target IES. I am Prakash Rajput, and now we have completed the required basics for electromagnetic field theory. Now we will move to our main topic, that is electrostatics. So, what is electrostatics? Basically, it deals with static charges. It deals with static charges. That is, charges will be at rest for the if when we are studying this electrostatic. So here the charges will be at rest position. They will be not be moving. Charges at rest. So what we will study in this, that charges in rest. What do you mean by that, the charges in rest? So if two charges at rest, if I take two charges which are at rest, then there will be some force existing between them. Suppose this is my q, this is my minus q. There will be some force existing between them. So what is that force? We will find that. And also, if a charge q, if a charge q is placed here, then due to this charge, at a certain point, there will be something, there will be something called electric field intensity. There will be something called electric field intensity, which is the basically the field of this charge. So that field is electric field intensity, and in that field, if I place a charge here, if I place a charge here, it will experiences a force. If the charge, if this charge, suppose this is q1 and this is q2, if this charge is far from the far from the field of this charge q1, then force will be lesser, and if it is near, then force will be more. We will see that. So here the charges will be at rest, and the charge at rest produces an electric field. So we will start doing that. So for our first topic is Coulomb's law. Our first topic is Coulomb's law. What is Coulomb's law? So Coulomb's law states that states that Coulomb's law states that if two charges, suppose charges are q1 and q2, two charges q1 and q2 are placed at a distance d, or rather I will take r, distance between them is r, then there is a force acting between them. There is a force acting between them. And by using Coulomb's law, we can find what is that force acting between them. So Coulomb's law states that force which is acting between them is directly proportional to the product of the charges, directly proportional to the product of the charges, that is q1 q2, and inversely proportional to the distance between them, and inversely proportional to the distance between them. And this force, suppose this is q1, this is q2, and this force will act along the line joining them. This force will act along the line joining them. So here if the distance is r, so I can combine both these equations 1 and 2, then I will get F directly proportional to q1 q2 divided by r square. And if I remove the proportionality sign, I will get a constant. I will write a constant here, k divided by r square. So what is this k? This k is proportionality constant, and its value is k is equals to 1 by 4 pi epsilon naught, and its value is 9 into 10 ki power 9. So 9 into 10 ki power 9, what will be the unit of this? Its unit will be Newton meter square per coulomb square. Newton meter square per coulomb square. And this value is for the free space. If it's a free space or a vacuum, so k value will be 9 into 10 ki power 9, which is constant because here epsilon naught is there. So epsilon naught is, what is this epsilon naught? Epsilon naught is permittivity of free space. Permittivity of free space. Permittivity of, so this epsilon naught is permittivity of free space, and its value is 8.854 into 10 ki power minus 12. 8.854 into 10 ki power minus 12. We can write the unit of this as coulomb square per Newton meter square. We can write the unit as coulomb square per Newton meter square, but it has one more unit, that is farad per meter. Farad per meter is also the unit of epsilon naught, that is permittivity of free space. And for simplifying the calculation, we can use this value also, 10 raised to minus 9 divided by 36 pi farad per meter. We can use this value also for epsilon naught. It's same as 8.854 in 10 to the power minus 12. So for simplifying the calculation, we can use this also. So this is about the force between two charges. Now this Coulomb's law has a vector form also. So we will see the vector form of Coulomb's law. What is that vector form of Coulomb's law? We'll see. Vector form of Coulomb's law. So to understand the vector form of Coulomb's law, you should know the position vector and displacement vector, which I have told you earlier. So let's consider two charges. Let's consider two charges in the rectangular coordinate system. Suppose this is my rectangular coordinate system, and here x, y, and z. I am considering two charges. Suppose this is q1 and this is q2. So this is my origin, and this is distance from origin to q1 and q2. Suppose this vector is r1 vector and this vector is r2 vector. I'll write here r2 vector. What are these vectors? These are position vectors of q of this point. Suppose this point is p point and this point is q point. So this uh, this is origin. So OP vector, this is the position vector r1, I said, and OQ vector, position vector for q2 I want to calculate force on Q2 due to Q1. So I am joining this line because Coulomb's law says that the force is along the line joint between them. So this is PQ and this will be the displacement vector actually. So I can write it as R12 vector, R12 vector, and you already know that R12 vector will be R12 vector will be R2 vector minus R1 vector. Displacement vector can be calculated by this formula. I have told this earlier also. So if we know the coordinates of point P, then we can find R1 vector, that is the position vector for point P. And if we find the coordinates of Q, then we can find R2 vector, and then we can find the position vector, displacement vector R12. So what the Coulomb's law says is force is equals to K Q1 Q2 divided by distance between them. So what is the distance between them? The distance between them is R12 ka magnitude. So we can write here R12 का magnitude and distance का square करना है हमको. This is the Coulomb's law. And now as the force is a vector quantity, so it will have a direction. So I am calculating force on Q2 due to Q1. So I can write this force as F12 because I am calculating the force on Q2 due to Q1. So the force will be on Q2 due to Q1 will be in this direction. So I can write this as F12. I can write this as F12. So F12 is in the direction like this, which I have made this arrow. So to give the direction of the force, I should write a unit vector in the direction of F12, which I have shown as this. So A12, or better I write R12 cap because it will be the same. So R12 cap. Now this is a unit vector, and you know that unit vector can be written as unit vector can be written as vector divided by its magnitude. Vector divided by its magnitude. So I can replace R12 cap like K Q1 Q2 divided by R12 का magnitude its square into R12 vector divided by R12 का magnitude. So this will be the vector form of Coulomb's law. So I can write it like this, divided by magnitude of R12 का cube multiplied with R12 vector multiplied with R12 vector, which will give the direction of the force. Basically this force is F12, which I have calculated in the vector form. So this is the vector form of Coulomb's law. In this, magnitude as well as direction is also there. Previously I have written kq1 q2 divided by r square. There were only magnitude. As force is a vector quantity, so its direction will be also given. So if I am calculating the force on Q2 due to Q1, this will be the formula for this. So I can write in the form of r2 vector and r1 vector also, like this. If I use a different pen here, so the magnitude will remain same, kq1 q2 divided by r12 cube. I should replace this r12 by r2 vector r12, which I have written earlier also. R12 is r2 vector minus r1 vector. So I can write the magnitude of this r2 vector minus r1 vector, which is the displacement vector r12, and its magnitudes cube. And for r12 I can write r2 vector minus r1 vector. So this is also the vector form of Coulomb's law. Here it is, magnitude. So this is the vector form of Coulomb's law. So this is the vector form of Coulomb's law. Now suppose if you want to find, the force on q1, due to q2, force on q1 due to q2. So it will be in this direction, and it can be said to be F21. So I can write an expression for F21 also. What will be that? So if I write F21, so the magnitude will remain same, k q1 q2 divided by, I will write r21, but the magnitude, that is the displacement between them, is same. The magnitude is same, only the direction will change. Now the vector will be written here, will be r21, and if I write in the r2 vector and r1 vector, it will be kq1 q2 divided by, here it's cube actually, r1 vector minus r2 vector, its cube, मैग्नीट्यूड का क्यूब. आप r1 माइनस r2 वेक्टर का मैग्नीट्यूड निकालो, फिर उसका क्यूब करो, या फिर r2 माइनस r1 वेक्टर निकाल करके उसका मैग्नीट्यूड निकाल करके फिर क्यूब करो, सेम ही आएगा. तो यू कैन ऑल्सो राइट हेयर r2 माइनस r1 का क्यूब, इट विल बी सेम, बट द डायरेक्शन विल चेंज. हेयर द vector which is r21 is r1 vector minus r2 vector. So if you see this expression, the r2 minus r1 and r1 minus r2, only this has changed. This magnitude will remain same, and k q1 q2 is also same. So you notice that f12 and f21 magnitude of f12 and f21 is same. The only difference is their direction is opposite. That is, we can write this, that f12 is negative of f21, or we can also write in different way, like f21 is negative of f12, because they are in opposite direction. So this is about the Coulomb's law and its vector form. Coulomb, Coulomb's law in vector form. Now we will see. I have taken earlier two charges which were of same sign, so the force was in opposite direction. Now if I take, suppose previously I have taken positive charges, now I am taking two negative charges, suppose minus q1 and minus q2, minus q1 and minus q2, and suppose this is from origin. If I make here x, y and z, this is x, this is y, and this is z, and these are the position vector r1 vector, and here r2 vector, same. R12 vector will be R2 vector minus R1 vector. We are going from 1 to 2, so फाइनल पोजीशन माइनस इनिशियल पोजीशन करना होता है आपको, यानी कि जिस भी डायरेक्शन में आप फोर्स निकालना चाहते हो, यानी कि जैसे हम निकालना चाहते हैं फॉर Q2, फोर्स ऑन Q2 ड्यू टू Q1, तो फोर्स अगर Q2 पर निकालना चाहते हैं ड्यू टू Q1, तो आपको जो डिस्प्लेसमेंट वेक्टर लेना होगा वो कुछ इस तरीके से लेना होगा कि जो फोर्स लोकेशन माइनस द सोर्स लोकेशन, so the force location is R2 vector and the source location is for Q1, that is R1 vector. So you can also write this like here, this is force location, just to remember this कि आपको क्या करना है एक्चुअली में, R2 वेक्टर माइनस R1 वेक्टर करना है या R1 वेक्टर माइनस R2 वेक्टर करना है। तो जिस पॉइंट पर आप फोर्स निकाल रहे हो, तो पॉइंट Q2 के लिए फोर्स निकाल रहे हो, तो पॉइंट हो जाएगा उसके लिए, तो उसके लिए फोर्स लोकेशन माइनस सोर्स लोकेशन, दिस विल बी सोर्स लोकेशन। इस तरीके से आप डिस्प्लेसमेंट वेक्टर निकाल सकते हो और उसके बाद फोर्स कैलकुलेट कर सकते हो। नाउ मूविंग टू द टॉपिक विच वाज कि अगर मैंने ये दो नेगेटिव चार्ज ले लिए तब फोर्स क्या होगी। सो इफ आई राइट F12, नाउ यू नो दैट लाइक चार्जेस रेपल ईच अदर, लाइक चार्जेस रेपल ईच अदर। तो अभी भी जो Q1 है वो Q2 पर कैसी फोर्स लगाएगा, इस डायरेक्शन में, जैसे वो प्रीवियसली लगा रहा था। तो नाउ ऑल्सो आई कैन राइट K, if I write minus Q1 into minus Q2, it will again become plus, and the displacement vector is R12 का magnitude का cube into R12 vector. So it is same. If I write F21, in its direction will be F21 is nothing but force on Q1 due to Q2. So it will also repel. So this will be the direction of F21, and it will also come same in case of magnitude, but the difference will be in the direction. So instead of R12 there will be R21, because I am calculating the force on Q1, so I will take this as force location and this as my source location. So I will do R1 vector minus R2 vector, so it will become R21 if I am going from minus Q2 to Q1. So this is if I take similar charges, then the force is uh, opposing each other, in the sense ki the charges are getting repelled. Now if I take one positive charge and one negative charge, suppose this is Q1 plus Q1, just to show that it is positive, and here I have taken minus Q2. So and they are in with respect to origin. Here if I show, so this will be again R12, and here this is origin, this will be R1 vector, this will be R2 vector. So the force on Q2 due to Q1 will be now in this direction, it will attract, this will be F12, this will be F12. So if you calculate now, F12 will come as K Q1 Q2 divided by, now it will again be like R12 का magnitude का cube, so Q1 Q2 will make it negative, and here R12 vector. Now you see that there is a negative sign, and due to this negative, the R12 vector which I have taken in this direction, that's why the force is coming negative. If I write this as K Q1 Q2 divided by R12 magnitude cube as R21, because minus of R12 will be R21 vector, because the force is now in the direction of Q1, because Q1 is attracting q2. Similarly for q1, now force on q1 due to q2. So q2 will attract the q1. So it will become k q1 q2 divided by r12 magnitude cube. You can take r12 here and here also because it is same. You will find the magnitude of r12 or r21. Magnitude will be same. So now here r12 will come because I have taken q1 q2. If I take minus sign here, so I will take the if I'm calculating the force on q1. So the displacement vector will be force location minus the source location, that is r1 vector minus r2 vector, which you call as r21, but the negative sign makes the r21 as r12. So I have directly written as r12. You can refer to previous thing which I have written, like if I show here that force on q1 due to q2 was kq1 q2 divided by r12 cube, and here I have written r12, and for force on q1 I have written r21. For force on a wait, it is here actually f21, yeah, here. So I have written here for the f21, that is force on 1 due to 2, it was r21 vector was coming here. ठीक है, यहाँ पे r21 वेक्टर आ रहा था. ठीक है, मैग्नीट्यूड तो सेम ही रहेगा, चाहे आप यहाँ पे r12 का क्यूब लिख लो, चाहे r21 का क्यूब लिख लो मैग्नीट्यूड का. ठीक है, वो तो सेम रहेगा. तो जब हम q1 पर फोर्स निकाल रहे थे ड्यू टू q2, तो फोर्स लोकेशन माइनस सोर्स लोकेशन करने के बाद ये r21 वेक्टर आता था. ठीक है, लेकिन जब मैंने दो अलग अलग चार्जेस लिए तब क्या हुआ, जब मैंने फोर्स लोकेशन माइनस सोर्स लोकेशन करा, दैट इज r1 वेक्टर माइनस r2 वेक्टर, I will get r21 vector, but due to this negative sign it will become r12 vector. I hope that's clear now. So this is about the Coulomb's law and its vector form and its different cases for positive and negative charges. Now previously I have considered only two charges. Now if there are many charges are placed, then how can we find the force on one charge due to all so many charges? So this Coulomb's law superposition. Obeys the principle of superposition. So I can calculate force on like if there are so many charges like q1, q2, q3, qn, number of charges n number of charges, and I want to calculate force on q2 due to these many charges. So I can calculate force on q due to q1 using the Coulomb's law. Then I can calculate force on q due to q2. Then I can calculate force on q due to q3. And then I can add all these forces in a vectorial sum. I have to take in vector form because force is a vector quantity and the direction will depend. Direction will make an effect. So I have to take vector addition. So I can add these forces in the vector form, and then I can calculate the total force due to all these charges on the charge q. So I can write this like, if I write force on q, force on q will be, suppose f1 I am calculating force on q due to q1. So it will be something like k q1 q divided by the displacement vector between them. The displacement vector between them will be, suppose this is what r vector and this is r1 vector, the position vector for q is r vector and the position vector for q1 is r1 vector. So the force I can calculate. I have told that I am calculating force on charge q. So the vector which I will use is force location minus the source location, that is r vector minus r1 vector. So I can write r vector minus r1 vector. So I can write here r vector minus r1 vector its magnitude cube, and here that for the direction r vector minus r1 vector. Similarly I can find f2. It will be something like k q2 q divided by r vector minus r2 vector divided cube multiplied with r vector minus r2 vector. If I want to find Fn, force on charge q due to the qn charge, it will be kqn q divided by r vector minus rn vector, force location minus the source location cube, here force location minus the source location. So this will be the charge on this will be the force on q due to charge qn. So if I add all of them to find the net force, to find the net force on charge q due to all these charges will be F equals to F1 plus F2 plus and so on up to Fn, and this is all the vector sum, not like algebraic sum. This is all vector sum. I have to calculate in vector form. So I can write in the simplified form that k will come out as common and the charge q will come out as common. I can write summation for the r vector minus ri vector and its cube, and here I can write r vector minus ri vector for the direction where I will vary from 1 to n, and charge also will come here. So this will be the force, total force on the charge q due to number of charges, due to number of charges. Let us see one question here. So what the question says, there are 4-point charges of 50 nanocoulomb each are located at these locations. So coordinates of the point charges are given. One is located at 100, at -100, at this location, and 0 -10 in the free space. Find the total force on the charge at A. So if I make the figure, well, there is no requirement of actual figure, but just for understanding I'll make the location. So as you can see from the coordinates, the location is in the xy plane. So I just need x and y coordinates, which I am making here. I just need x and y coordinates. So it is my x-axis, it is my y-axis. So A charge A is at 100. That is here. Suppose this is 100, and B is at -100. So this is -100. This point will be B, and C is at 010. So this is the location 010, every location the charge is 50 nanocoulomb, and I want to calculate the force on charge A, the charge present at A. So by using the principle of superposition, I can write force at A will be K Q. Suppose the charge at A is Q, or if I write QA, as all charges are same, I will write Q only. KQ divided by later summation. If I write I equal to, as there are 3 more charges, so I equals to 1 से लेकर के 3, and all charges are same, so Q will be same here. And if I write the R vector minus RI vector, force location minus source location, cube, and for the direction R vector minus RI vector. So here R vector, what is R vector? It is the position vector for the force location. That is, R vector will be from here. If I find the position vector, it will be AX cap, and all the other components will be 0. So only AX cap will be the R vector. So I will write what is R vector, AX cap, AX cap. And if I want to say that what is R1 vector, so R1 वेक्टर विल बी, कोई भी आप चार्ज जो है 1 2 3 करके अज्यूम कर सकते हो. जैसे कि मैं इसको फर्स्ट चार्ज मान लूँ, तो ये R1 वेक्टर हो जाएगा इधर से इधर तक. ये R1 वेक्टर हो जाएगा फोर्स लोकेशन माइनस सोर्स लोकेशन. ये इधर से फोर्स लोकेशन माइनस सोर्स लोकेशन करके इधर से आप R2 वेक्टर कंसिडर कर सकते हो, और इसके लिए R3 वेक्टर आप कंसिडर कर सकते हो, फोर्स लोकेशन माइनस सोर्स लोकेशन. So I am finding force on A. So this will be R1, and this will be R2 vector, and this will be R3 vector. So if I write these all these vectors, so R1 vector will be, is actually the position, not R1 vector actually. Actually I have to write position vector. So because the R1 here, this RI vector is the position vector for different charges. So the position vector for this will be, suppose R1 vector, and for this will be R2 vector, and for this if I take this as R3 vector. So I can write R1 vector. R1 vector will be there, here it is R1 vector. It will be in X component, it will be 0, only Y component, so it will be only AY cap. And if I write R2 vector, R2 vector will be minus AX cap, and R3 vector will be minus AY cap. Now using the formula, if I put the values, F is equals to K, Q will come out and it will make square, and I can write here the first part will be R vector minus R1 vector. So it will be AX cap minus AY cap. So its magnitude will be AX cap minus AY cap. Its magnitude will be 1 square plus 1 square, and I can write AX cap minus AY cap plus R vector minus R2 vector, that is AX cap minus of minus AX cap will make it as 2AX cap, and its magnitude will be, its magnitude is 2 only, still I will write as 2 square, then I will put a cube here, here also the cube, and final one is R minus R3, so it will be AX cap minus of minus, that is plus AY cap, and the magnitude will be 1 square plus 1 square and its cube. So if you solve this, what is the value of k? 9 10 ki power 9. What is the value of q? 50 into 10 ki power minus 9, because 50 nanocoulomb square. If you solve this, it will come like ax cap minus ay cap, and it will become 2 root 2, and root 2 cube will be 2 root 2 plus here 2ax cap, and 2 will come out, and it will be 8 plus ax cap plus ay cap minus, it will be again 2 root 2. You can see the y component gets cancelled. Y components gets cancelled, because here also, if I show, here also minus ay divided by 2 root 2, and here plus ay cap divided by root 2. तो जो ax का ay का component होगा वो cancel हो जाएगा, and if you simplify the calculation, the total force will come out will be 21.5 ax cap micronewton. The force is in micronewton actually. So this will be the total force, and we can easily find this using superposition principle. Now let us see one more question based on Coulomb's law. It has come earlier also in SC. So there are two charges of equal magnitude are separated by some distance. If the charges are increased by 10% to get the same force between them, so their separation must be, what will be their separation must be done if it is increase, decrease, whatever from the given option. So let us say previously, like first in for the first case, the charges of equal magnitude are separated by some distance r, and we know that F is directly proportional to q square by r square. I have written q square because they are having same magnitude. Q into q will become q square. So as you can see, the force is directly proportional to q square by r square. So now the charges are increased by 10%. So now the charges are increased by 10%. So in the second case, the charges will become 1.1 of q, and it will also become 1.1 of q. Now the forces are same, because we have to get the same forces, so their separation must be adjusted. So what will be that separation? So if I use this relation, I can write q square divided by r square. Suppose in the first case the magnitude were q1 and separation were r1 square equals to q2 square. In the second case the charges are q2, that is 1.1 q and 1.1 q, and the separation becomes r2. So I can write this as q1 by r1 equals to q2 by r2. So if I replace q2 by 1.1 q1, which is the first case, q1 is equals to q1 by r1 is equals to q2 will become 10% increase of charge, will make it 1.1 q1, and r2. So if I solve this q1 and q1 gets cancelled, and r2 will come as r2 will come as 1.1 times of r1. So you can say that the separation is also increased by 10%. So you can see from the given option, the answer will be increased by 10%. That is option B will be the correct choice. Let us see one more question. Here, four charges are arranged at corners of a square as shown. So force on charge kept at center O will be, I have to find force on charge which is present at center of the square. So here the charges are like here plus q, here also plus q, both are having same charge, and here plus 2q, and here minus 2q. So if I find force, let us say if I place a charge at the center of 1 coulomb, plus 1 coulomb, I have placed a charge of plus 1 coulomb here. So what will be the force due to charge at A? It will repel it. So suppose this is my FA. And what will be the what will be the force due to charge at C on this force? It will also repel it. It will be in the direction of this. So here, I better write it FC. Here FA and FC will be same because the magnitude is same of the magnitude of charge is same, and the distance between them is also same from here to here, like OA and OC will be equal. So FA and FC will be equal and they are in opposite direction. So FA and FC will cancel each other. FA and FC will cancel each other. Now we see the force due to charge at B, that is plus 2q. It will also repel the plus charge. So force due to this will be FB, and the minus 2q charge here will attract this charge, so it will be in the same direction as of F, as of FB. So suppose this force is FD. As these two forces are in the same direction, so the net force will be along the BD, will be along the BD. So from the given option you can see that the force is along BD. Now I have taken here plus 1 coulomb charge. I can take negative charge also, then also the answer will be same. Let us see for minus 1 coulomb charge what will be the answer. Let us see if I place minus 1 coulomb here. So Q will attract this charge, the charge at A will attract this charge, so FA will be in this direction, and this will also attract, the charge at C will also attract, so FC will again FC will also attract this minus 1 coulomb charge. So again FA and FC will be equal, and FA and FC will cancel each other. Now what will charge at B do? It will also attract, so FV will be in this direction, and charge at D will now repel this charge because it is negative and it is also negative, so it will repel this charge. So you can see the force FD is in the direction with FB, so again the net force will be along BD, we can say along DB, but as we can see that it is along the diagonal. So we can now come to the conclusion that force is along BD diagonal. So C option is the correct choice. So this is all about the today's lecture. We will continue with the next topic, electric field intensity, in the next lecture.